Hello. Okay, now you should see the desktop now, and you should hear me. Let's see. Let me get the chat up. Okay. Is everything saying okay? Do you hear? Do you see the desktop and you hear me okay?
Yeah.
Yes.
Okay, great. Thanks. Okay. Uh, okay. Well, I'm sorry about Tuesday. Um, yeah, I had to go to a hospital because my blood pressure was going up and down, and my heart rate was heart beating very strangely, and so my doctors sent me to a hospital, but nothing came out of it. There was, I think I'm okay. So, but that's what happened on Tuesday. All right. So let's see. Oh, I want to take the exam you took last week. I'm halfway through grading them. I may be able to. I'm halfway through grading them. I may have them done by tonight or tomorrow. So look for exam 2 in the grade book on Brightspace. When you see the exam grade show up, you should be able to click on the grade. I'm not sure what you click on, but you should be able to see the document that you uploaded because I write comments on it. So like your score for each problem will be on that document, and there'll be comments about, like, I circle things if they're wrong, or I make a comment about how you could have done things a little bit differently. So don't just look for your score, look for your exam document and open it in Brightspace, and you should be able to see the markings I put on your exam. And one real important thing I want you to do is add up the points, because they don't have an automatic point thing. So I give you points for each problem, and then I have to add them up at the end to get the total score. And it's really easy to make a mistake doing that. So add up your points to make sure that I added them up right. But then if you have questions at all about how anything is graded, please send me an email or come to office hours. We won't go over the exam in class because everybody will have different questions. Usually when people have a question about the exam, they have very specific questions about how they solve the problem. So I'd rather people ask me questions directly about their exam than to go over the exam in a real generic way in class. So we won't go over the exam problems in class, but if you have questions at all about your exam, about any solution or how a problem was graded, please send me an email or connect with Zoom. So either late tonight or sometime tomorrow, you should see exam 2. And then in a couple more days, I'll try to have exam 1 up there graded also. Okay? So yeah, exam 2 is halfway graded, so maybe tonight or by tomorrow sometime in the afternoon, I'll have that finished. Okay? And I don't really know, you'll see I'm not really sure how you see your exam. I know you can see it. Maybe it, yeah, you'll see your. Actually, does anybody know? Like, if has anybody done it in another class? Is there anybody who knows exactly
Yeah,
what do you do?
it will have, so it'll have your grade, and then it will have next to it, like, at least for my math class, it's an inline feedback. And so for that, we upload a PDF like we do usually for the exams that you have. And then on it, he'll put like check marks, or he'll write in there what's wrong.
And
And
when
it's
you
just a
click on a
PDF
link,
you open.
you
Yeah.
click on a link, and it opens your document for you.
Yeah.
Okay. Yeah, and that's. I mean, I use there's a little tool in Brightspace. It's actually pretty nice. It lets me circle, and I can write comments on your exam. I can circle things, underline things. So I tried to point out where you made mistakes or where something could have been done differently, and and also you see how many points you got for every problem. So definitely when you see your score, go look at the exam itself. You could probably print it out if you wanted to copy, and it'll probably print with the annotations on it too. Okay, so please look for that soon. Okay, then what we're going to do is we're going to start talking about a new topic. We have to start covering one of the major other topics of this semester: arrays. This is one of the 3 or 4 really important things in programming. Methods, loops, if statements, and arrays are pretty much most of what this semester is going to be about. So what we're going to do is I got some examples on my computer. I'll put them up on the website after class. And I want to show you an example to show you why why we need something called arrays. So I'm going to open this in Dr. Java. Let me get Dr. Java running. It takes a second for it to start. Okay, here's a simple file. What it does is see here, it reads a series of temperatures and reports the average. Okay, so let me compile it and run it and you'll see what it does. Then we'll go through the lines of code. Okay. It asks you how many days of temperatures are there. So I'll say that I have 5 days of temperatures. Then it's going to ask me for the temperature of day 1, say it's 56. Temperature of day 2, say 78. Temperature for day 3, 44. Temperature for day 4, say 23. And temperature for day 5, 88. Kind of dumb temperatures. Okay. And then after it's got the 5 temperatures, it tells me what the average was. So it's just actually just asking for, it asks you how many numbers that you're going to give it.
Oh, okay. I was about to say, how does it know that? Okay.
Pardon me?
Oh, shoot. I'm sorry. I didn't know it was unmuted. I was just talking to myself.
Okay. Yeah. Okay. So the program first asks you how many numbers you want to give it. Then you give it that many numbers. Then it tells you the average. Okay. And the code is pretty straightforward. We need to create a scanner to be able to ask the user for input. So there's creating the scanner. Then we prompt the user saying, tell us how many days you want of numbers, how many numbers you're going to input. Then here from the scanner is named console. From the scanner, get the next int. That's the number of days. Okay. Then we declare, no, we're going to compute an average. To compute an average, you add up those scores and divide by how many there are. Okay, that's how you create an average. You add up those numbers and divide by how many there are. So we need to be able to add up those numbers. So we create a variable that's going to be the running sum of those numbers. So I create a variable sum and started at 0. Now I need a for loop to loop that many times, because that's how many numbers I'm supposed to read. So then I ask for day I temperature. So that's day 1, day 2, day 3, day 4. I read another number from the user and I store it in a variable. And then I add it into the sum. Okay, so this becomes a running total. And each time I loop through, the user's new number gets read into that variable, then gets added into the sum. Then when I've got that many numbers, I say compute the average. Now this thing holds the running total. This is so there's that's the running total divided by how many numbers there were. That gives me the average. Now I have to do a little trick here. The temperatures are all integers. Okay, and this is an integer sum. But the average isn't going to be an integer. The average of 3 and 4 is 3.5. So the average of integers is going to be a double. So if I don't have this thing here, then this divided by this won't be a double, it'll be an integer division. I don't want this to be integer division. So I say that I want to convert this to a sum and then do the division. Okay. Actually, in hindsight, this thing should have been written to use doubles for everything. You know, the temperatures should have been doubles to begin with. I'm not sure why I wrote it to do integers for now this one, obviously, that's the number of days, that's an integer, but it should have just been, this is a double, this should have been a double, this should have been next double. Should have been, all the temperatures should have been doubles. And then it wouldn't need this down here. Yeah, so that would make the program a little bit better, actually. There's no reason to think that temperatures are ints. They should really be doubles. But so there's this little quirk here, because this is an int, this is an int, and integer division, remember, is without the remainder. Integer division, 3 divided by 2 is not 1.5, it's just 1. It's how many times does this go into this? It's quotient without the remainder. But that's not what I want here. I want regular division, so I have to convert that to a double. And then the answer gets printed. Okay. Now, here's what I want to do with this program, but I don't know how to do yet. I'd like at this point to say how many days were above average. Okay, so I know that, so I have here's my data. These are my temperatures. There's my average. And I can look and I can see that above average, above average. 2 of the 5 were above average. Okay, so but I'd like the program to figure that out. Okay, now there's something stopping the program from figuring that out. When I read in a number, I don't know what the average is yet. So I can't tell if that number is above average or below average. Why do I not know what the average is yet? What's a little problem here? I read in a number. I'd like to compare it to the average to see if it's above average or below average. Okay, but what's the problem?
You're still in a loop.
Yeah, but why can't I just compare this to the average? What stops me from reading a number and saying, oh, that's above average?
The average hasn't been declared yet.
Because and why is the average? What's true about to compute the average? I need what?
The sum,
The sum of what?
the temperatures.
All of the temperatures. See, it isn't until I've read all the temperatures that I can compute the average. Okay. Now, so think about what would I need to do to be able to find the number of days above average? Can you think of what would be some strategy that would let me figure out the number? Like here, I read in all the temperatures one at a time. Okay.
You could put an if statement within the for loop.
And do what?
And then so you could declare an integer outside of the for loop called count, and then declare an if statement inside the for loop.
But
and
what would
say,
yeah.
And with every number you compare it to the average, and with the if statement you say like if it's above the average, count plus plus.
Yeah, that's what I want to do, but I can't do that. That's what we see. What's wrong? You want to compare the number to the average, but you can't here. Why? Because the average, we don't know the average until after this for loop is run. See, it isn't until there isn't I could have averaged those two numbers there, but that's not my average for all the temperatures. So I can't average, I don't know this number until I've read all those numbers. So it isn't until this loop is over with that I can compare averages, that I can compare a number to the average. Okay, so I have to read all the numbers, compute the average. Then what do I want to do after that?
Could you just do what I said before, but write a second for loop?
Yeah, okay, a second for loop. But then where do the numbers come from now? So exactly, I do what you said, but in a second for loop. So there needs to be a second for loop. Okay, but here's the question now. Where do the numbers come from in the second for loop? Whoops, actually that second for loop should be after we computed the average. Okay, second for loop, and actually now, right now, I can do exactly what you said. Okay, but where, notice that if that would go here. I would say if next is greater than average, I want a counter plus plus. So we can put a counter here, int counter equals 0. So that's exactly what you said. Create a counter, and then loop through, get each number, compare it to the average, and if it's above average, increment the counter. But what am I actually doing here? Where are the numbers coming from? Where's this number coming from?
Your first for loop.
No.
User input.
User input again. Essentially what am I doing here? Think about the structure of this program. What is it doing to solve the problem of find the average temperature, then find the number of days above average?
Maybe So, like, is there a problem with you need like a way to store the user input so you can refer back to it in the second loop?
Yeah, that's exactly what we're getting at.
So,
That's exactly.
so
But what am I doing right now though? I don't have that nice thing. I don't have it. I don't have a way of storing them. So what am I doing here?
You're making the users to put the temperatures twice.
Yes, exactly. I'm forced to ask the user 2 times. I'm asking the user for all the numbers once to compute the average, twice to find the number of days above average. And what I want to do is, like you said a minute ago, I really would like to store these numbers so that I don't have to go ask the user for them again. That's what I would like to do, is store them. Now, why don't I just create a next 1, next 2, next 3, next 4, next 5?
Because they're local variables.
Oh, that's okay. I could do them up here. I could say int next 1, next 2, next 3, next 4.
Could you store it in an array?
Well, that's what we're going to get at. But what's wrong with this?
How do you know it's only 5 days?
Yeah, how many days? See, I don't know how many days someone's going to tell me. Like, what if they tell me I'm going to give you 27 days? I would need 27 variables to remember what they gave me. So using variables to remember the data isn't going to work, because I need a variable for each day. And that's not going to work because I don't know how many days there are until the program runs. Okay, so now we can finish this program and it'll work. The only thing I need to do now is print out little message, number of days above average is counter. Okay, so this should compile. Okay, and run it. Okay, I'm going to do 5 days. Now watch. I want to keep, well, let's say 44, 55, 66, 77, 88. Okay. Now, the average was 66, but now I want to know how many days were above average, but I have to type them in again. 44, 55, 66, 77, 88. Okay, now is that the right answer? The average was 66, and 77 and 80 were the 2 above average. But see, I had to type the numbers in again. Our goal is that when these numbers are typed in the first time, we remember them. And then the second loop would use the remember numbers. We want the second loop not to ask for the numbers again. We want the second loop to use the remembered numbers, but we don't know a way yet to remember a large amount of data. So because I could make this program, well, I could run it again. And I mean, I could say I'm going to give 100 data points. Now I'm stuck entering 100 values. Yeah, that's going to take a while. And then I would have to enter them all over again. So this is not real useful. But how can I store 100 values? Or for that matter, even 1,000 values? There's nothing to stop my program from having 1,000 values. In a little while, I'll show you how you would do that. That you could actually literally have your program read 1,000 values, but you don't type them in, you put them in a file. And then you would read them from a file, so you would have the data in a data file. But this program will work I can make this program work with a data file and have holding 1,000,000 numbers. But how do I remember 1,000,000 numbers? I could read 1,000,000 numbers from the data file using a scanner, just like this, and I could read them again from the data file. So I could read the data file 2 times. But it would be better if my program just remembered the numbers. Okay, so an array is a way to create, what I really need is a bunch of variables. I really need this many variables, but I'm not going to call them like next one, next two, next three, next four. I want to create them in a more organized way. So let me switch to the Java Visualizer and show you what we mean by arrays. So we know that we can see what it is we're trying to do. You know, the idea is, what if a program needs to store a large amount of data, and in the worst case, you don't even know before the program runs, like in this case, you don't even know how much data you're going to need to store until you run the program. Because every time I run this program, I could give it I could say, oh, 1,000 temperatures, or 5 temperatures, or 20 temperatures. So I don't know how much, I need to store a large amount of data, and I don't even know how much. Okay. Now, here I'm going to declare a new kind of variable. So I'm going to declare a variable int. I'm going to put a square bracket, a pair of square brackets after it. And I'm going to call it temps for temperatures. Oops. Okay. Now, and then I'm going to say new int 20. So here's a declaration of an array. Okay. Now let's visualize it and we'll see what it did, and then we can explain it. What it did was it created a variable called temp, and over here where objects are, we're creating an array. Is an example of an object. An array is an object that holds that many of that kind of variable. Okay, so an integer array is 20 integer variables. So over here are 20 integer variables numbered from 0 to 19. Okay, let me do another one. Let me do it as a double. So double square bracket temps 2 equal new double. Now I want to create 20 double variables. Okay, so I'm creating 20 double variables all at the same time, and this is the name I'm giving to the group of 20 double variables. Now notice that the visualizer is a bit odd about this stuff. Notice that for the 20 ints, it wrote the first one, then dot, 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 and then the last one. It didn't show me the ones in between. But for the doubles, it showed me that I have 20 variables, numbers 0 through 19, and they're initialized all with 0. Okay, so I've got 20 variables. Now notice how easy it is to create 20 variables. In fact, I can make these 200. The visualizer won't show me the 200 ints, but it'll show me the 200 doubles. And I have no idea why it does one but not the other. Notice that the 200 ints, it just says dot, dot, dot here. So there's the first one, the second one's there, and the third one's there, but it doesn't show it to me. But if I do the doubles, there's 200. There's 200 doubles. Yeah. If they went through the bother of showing you 200 doubles, I'm not sure why it doesn't go through the bother of showing you 200 ints. I wish it did show you the 200 ints. The dot, dot, dot's a little bit annoying. Okay. Now, how do I put numbers in there? Okay. So this is what we call array declarations. Now, let me put a piece of data in. Now, when you declare an array, it gets a default value. In this case, it was 0. In this case, it was 0.0. Like if I want to, in temp, in the 5th variable, I can put the temperature, say 27. So this is how I access one of the variables. Remember, there's 200 of them, and here's the 5th one. It gets a 27. And if I want, I can put into the 105th one the number -2. Okay, and in the double array, Oh, I forgot S is there. And in the double array, I can do similar. I can, like at entry 5, I can put the number 27.3 and okay, at 105, I can put a number in there. Now, all the other numbers will stay 0. I'm putting numbers in just 2 what we call entries in the array. This is the 5th entry in the array. Actually, it's the 6th entry in the array, because when we go back and we look, the arrays count starting at 0. So the entry with what we say index 5 is the 6th entry. The entry with index 105 is the 106th entry. Okay, and if you want, I can put something in the first entry, the 0th entry. So there's putting something there. There's putting something in the first entry. Okay. The index 0 is the first entry. Index 5 is the 6th entry. Okay, and I put a number in here. I'll put like negative. Okay. Now let's just visualize this.
I have a question.
Sure.
So for the second, so for the problem we were doing earlier, where we're gonna try to store the data in an array, so we don't have to ask the user twice. So like when you declare an array, you have to declare, you do have to declare how long the array is, right?
Yeah.
Okay. So my question then is, so what happens if the user like just goes over the length of the array? Does that mean you have to set a maximum number?
No, no. It turns out Java's really well designed.
Okay.
What did it see this number here? That's the user telling us how many numbers they have, right? So here's what we're going to do.
Oh, okay. Oh,
We're going to use that for the
no,
yeah. We're going to say
now.
Yeah, int temps equal new int, and then the clever thing is use num days as the size of the array.
So what if I didn't ask the user how many days?
Yeah.
Okay, so then you just have
Yeah, you either have to make a wild guess at a size of an array, or you'd have to like when you reach the limit of the size of the array, you'd have to just stop reading numbers.
There's no way that you could like change the size of the array or anything like that?
Oh, that's a real good question. The answer to that is yes and no. Everything is answered in computer science is yes and no, or another way to put it is it depends. The answer is no, you can't change the size of an array. But the other answer is, but you can be clever. When you hit the size of your array, suppose you made the array 100 and you filled it. As soon as you see that the array is full, you create a second array of size 200. You copy everything from the array of 100 into the array of 200, and then you go on. Then if the array of 200 fills up, you do the same thing again. When you see that it's
oh, sorry to interrupt.
Yeah, what happens? So when you see it's full, you do what?
Well, so you make another array, but okay, so I'm thinking about like what the code would look like for that, and wouldn't you have to write a for loop?
Yeah,
yeah.
A
nested for loop. So then how would you like do that indefinitely so that you could just like keep going on and on?
Well, it's going to be, it's not just 2 or 3 lines of code, but we'll see it eventually. Yeah,
okay.
And if I bet if you went home and thought about it, you could probably figure out how to do it. You're going to have to keep track of how big your array currently is and how many numbers you've put in it. So you need like a couple counters. And every time your counter of how many numbers are in the array hits the size of the array, you have to stop, make a copy of the, make a new array that's twice as big, copy everything from the old array to the new array, and then start going on with the new array.
Mhm.
It's a bit of code, but it's not that tricky.
Yeah,
And-
you can do it.
Yeah, and it's done all the time. You'd be surprised how many real life programs do exactly that trick.
Okay.
It's just ubiquitous. You don't, unless you ask somebody ahead of time, like we're doing here, unless you ask ahead of time how big the array should be, what almost all programs do is if they don't ask this, they do exactly what we just said. They just create an array of size 100. If it gets filled, they make another one of size 200, copy all the data from the size 100 to the size 200, and start filling in there. Then if it fills up all the 200, they just make another array of 400, and the strategy is usually to double the array every time. Okay. And that pattern, you'll see it over and over again. And as you learn more about programming, you'll see that that's really what people do. Some
Okay.
people do this of asking ahead of time, how big should the array be? Okay, so that's one strategy. Just ask ahead of time how big the array should be. And the other strategy is just make a wild guess, but then grow the array as you need. Now, some programming languages do allow arrays to grow as you put more data in them. JavaScript is like that, and Python is like that. You can just keep adding things to an array, and the array grows as you add things to them. Java doesn't work that way, and C and C++ don't work that way. Okay, but some languages do work that way. That if the array is size 100 and you add 101 item to it, the array grows. Oh, what happens here? Okay, temp. The array is size 200. Now, notice.
Oh, that's out of bounds, I think.
Right. Now, look at the end of the array. Notice that 200 items are numbered 1 to 199. There is no item numbered 200. That causes confusion. Because we started counting at 0, the last item is 199. Okay. What happens if I try to put something in slot 200? So temps 200 equal 5. Okay. Notice it compiles. The compiler doesn't even pay attention to what I wrote there. But let's see what happens when we get to it. Our program essentially blew up. See here, our program blew up. In fact, to show you that it really blew up, let me move that higher first. Let me move this here. Okay, so first thing I try to do is put something at the overflow. We call that overflowing the array, going past the end of the array. Now notice my program blew up. See how forward is grayed out? I can go backwards, but when I execute line 5, see, I cannot go forwards anymore. My program has thrown an exception. It's blown up. And you can see what it said, array index out of bounds exception. 200 is too big of an index. There is no entry 200 in that array. Okay. So now some languages would just grow the array. When you put something in, when the array has a certain length, and if you go past the end of the array grows with it. But not many languages do it that way. The array length is fixed. If you go past the end of the array, you get an error. Your program crashes. Okay? All right. Notice how easy it is to create huge amounts of variables. See, this is what we want. We want something that creates a huge amounts of variables. If I really wanted to, I could prompt the user for these numbers here. I mean, I could even, just like here, if we want to use a scanner, we can go over here and we can say, I want to use a scanner. And before creating the array, I want to, well, just like over here, first I need to create a scanner object. So I'll create a scanner object, okay? And then I'll just create a int size equal, I won't bother prompting. I'll just say int size equals console.nextInt. Okay, just like over here, just like here, I'm going to read in the size of the array. And then I can use the user input for the size of the array. Now notice I don't know how big it's going to be now. See, this program doesn't know yet how big the array is going to be. Until I run it, this is one of the beauties of how Java works. Until I run the program, I don't even know how big my array is going to be until I run it. Now, the way the Java Visualizer works, if I want to read input, I have to put the input in a little box here. So here I'll put the size of my array. I'll put 20 here for the size of my array. So I have to give it the input number before running the program. Okay, forward. Okay, I'm about to create the scanner object. Now read in that number into the size variable. Okay, now size variable is there. Now I can create my first array. And I've got an array with 20 items. See, so my program didn't know until it started how big that array was going to be. And the next array also has 20 items. Okay. Now my program, again, oh yeah, this is going to blow up because there isn't a 200th item here. Okay. So let me comment that out here. Well, actually, I could run my program again. Oh, let me see. Make it a size 250 array. Okay, now that one will work fine. Make it size 250. Forward. Okay, there's the size variable. Now use it to create the first array. There's an array of 250. There's an array of 250. Scrolls way over here. See, it goes up to 250. Okay, and now we can see, now I put 5 in entry 200. Let's go look for it. Oh, which array did I put it in? I forgot which one I put it in. Oh, not the doubles. It was in, see, it's there. See, so see, this one uses ... to mean there's a bunch of entries between 0 and 199. Then there's an entry at 500. Then there's an entry there's an entry at 200, then another entry at 201. Then there's a bunch more entries, which is not showing you until you get to 249. Okay, if I go back over here, I can do that in the other array. I'll put something at slot 200 in the other array. What did I do wrong?
Misspelled temp. It's a T.
Oh, yeah, I knew. Okay, I'm sorry. Thanks. Okay. Okay, now this one. Now there's the entry 200 in the compacted array. They don't show you the whole array. They use these ... to show you the parts that are all to kind of skip over the parts that are all 0. In the other array where they're showing us the whole array, we go out here to 200. There's the 5 out here at 200. Okay, so we can notice that these arrays are what we call random access. You can put something anywhere in the array. It's called random access, but there's nothing random about it. What they mean is you don't have to fill the array starting at the front, then go. You don't have to fill it in from front to back. You don't have to fill it in any order. You could fill it in a random order, so they gave it the name random access. So you can just sort of pick an entry and put a number in there, then pick another entry and put a number in there, then pick an entry and put a number in there. By far and away, most of the time, you fill up arrays from beginning to end. You know, most of the time, you fill an array from the beginning and you work your way down the array to the end. But you're not required to do that with a Java array. In some languages, you are required to fill an array from beginning to end. But Java arrays are what we call random access. You can just punch a number in anywhere in the array you want at any time. You can access any element in the array. You don't have to do it in order. Though doing it in order is often the most efficient way to do things, you're not required to do it in order. Okay, so we have the ability to create arrays, declare arrays, and we can put things in the array. I can also do things like the following. I can copy from one array to the other. So I can say temps to his entry 77 should equal whatever is in the other array at entry 0. That's going to copy from one entry of one array is going to be copied to another entry in the other array. Okay, notice that this one here holds a 44, so that should put a 44 over here. So you can copy from one, or they're just the regular variables. So you can copy from one variable. You think of this as a variable. This name is the name of the array. When you put a square bracket and a number and a square bracket after the name of the array, think of that as a single variable. As in this case, a single int variable. Here, it's a single double variable. And you can copy from that int variable to that double variable. Okay, so you can just treat them as individual variables once you give them the index number. So if I go up here, okay, now 44 is in this array slot 0. Right now, if I look at array slot 77, it's empty. It's got the default value of 0 in it, but I'm about to put a number in there. So I go over here and I execute that line of code. And then I go back over here. And slot 77 now has the 44 in it. Okay, so I can copy numbers. I copied that number from that array into the 77 slot in the other array. Okay, so these are regular variables. Okay, so once you've declared an array object, once you've created an array object, you can treat the entries in the array as variables, and you can use them in any way you would use a variable. The name of each variable is the name of the array, left square bracket, the index of the particular entry you're interested in, then close square bracket. That's an array entry. Okay. All right. Now, what else? Let's see. Now we can go back to our program over here, and now we can fix this. Okay. So now we've got that part of code there, right? So now this line should change. Okay. Why should this line change? What do I want to do there? I'm reading the data from the user.
Store the data to the array.
Yeah, put it in the array. Put it in one of the slots in the array. Okay, but which slot should I put it in?
The I slot.
Yeah, because I'm counting the number. Remember, I was the day. Oh, be careful.
I minus 1.
Yeah, because see, I started I was what?
1.
1, but arrays start with
0.
Yeah, so this would be I minus 1. So then I read in the date. Then I add in what here?
Temps.
Temps I minus 1.
Yeah, the same number. The variable we just used, we want to add it into the total. Okay, so here's where we put the the ith day goes in his slot, and then we add in the ith day into the running total. Okay, all right, all right. So now we've remembered all the, we've done two things at once. We've remembered all the temperatures while we've created the running total. Do we change anything here?
No, that's fine.
That's okay so far. Okay, okay. Now now we want to change what we do here. Okay. Do I change this line?
Yeah.
What do I do with that line?
Delete it.
Delete it, because I don't want to, yeah, I don't want the user involved anymore. Now it's not the user who's going to give me the data. Okay. What about
you
the
can
next
get rid
one?
of the next as well. Right.
Oh, where was that? Which line?
32.
Yeah, I'm sorry. Yeah, 32. Because we're not going to read it from. But I don't want to get rid of this line. I want to replace it with something else. Well, actually, no. I guess delete it. What do I replace this with?
Temps I believe.
Oh,
Oh, I-1.
well, but
That
you're
one.
right. What should we do now? Since we're not talking to the user, let's go ahead and make this 0
Just 0, yeah.
to strictly less than number of days. So then we can just do, since we're not talking to the user where we're saying day I, let's go ahead and make this I equals 0, I strictly less than num days. So then we can make this I, okay? If temps I is above average, count it, and then count the number of days above average, okay? Now we should be able to run this now. Let's see, compile. Run. Okay, I'm going to do 10 data points. Since I don't have to do them twice, I'm going to go ahead and splurge and give it 10 data points. Okay. Well, okay, so let's look at the average was 48, and it claimed that there were 5 numbers above average. By coincidence, I wasn't even thinking about what I was doing, but I got by coincidence half of them was above average. Okay. Okay, let's check it. The average was 48. No, no, yes, 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 yes. Okay, 5. Yeah, I counted 5. Okay, so the ones above average were 3, 4, 6, 8, and 10. Okay, so it worked. Notice the user did not have to re-enter the numbers. Okay, so now that would work. You know, and that's kind of nice. It's more convenient from the point of view of the user. And if I wanted to, I could make this work with huge numbers of data if I wanted to. I could change this later on in the semester. We'll see how we could go back to this program and let it read massive numbers of data, like 1 million numbers or 10 million numbers. One of the things I want you to start getting used to is in real programming, you don't do 10 of anything. You do 10 million of things. You know, that's what real programming is about. Especially in Google world, it's never even 10 million of anything. It's always 10 billion. Literally, they work in the billion. Almost, if they do anything, they do it in the billions. Yeah, they don't even do things in the millions. The thousands and the millions don't really mean anything to them. You know, there's what's the population of our planet now? Is it like 5 billion people?
7 billion.
7 billion? Yeah, to Google, everything is in the billions. You know, there's almost nothing they do that they don't measure in the billions. Okay, so we'll see how we can get this to work with but then we have to put the data in a file. Yeah, if we're going to work with that much data, we have to usually put it in a file. Okay. Actually, no. Let me show you. Let me show you something that can work with 1 billion. So let's look at another example. Actually, here's an example here, which we can do something where we can work with a huge amount of data. Okay. Now, one of the things we're going to talk about let me go back to the course website and look at the reading assignments. Notice that the reading assignment was array creation and access. That's what we've been talking about, this 7.1. And we've also kind of been talking about 7.2, traversing an array. In our example, this would be counted as a traversal of the array. What we did is we started at the beginning of the array. I'm sorry, that's not this is the example we did. We started at the beginning of the array, and we went to the end of the array, and for every element in the array, we did a test on it, and we did something. So we traversed the array from beginning to end, okay? So in the books, that's usually called traversing an array, okay? So that's an important idea, that just to think of that, when even though the arrays are what we literally call random access, you could skip around in an array like crazy if you wanted to. Rarely do programs skip around in arrays. Programs tend to traverse an array, meaning you start at the front and start at index 0 and just step through the array one by one with a loop just like this, step through the array to the end. Now, here's something I can do better. The end of the array should really be called this. That's actually the end of the array. Okay, so I created the array of that length, so that number and this number are the same. But a better way for me to write my loop is this way, so that if I want to change that variable, for example, suppose I decided I don't like that variable name, so I want to change it. Then I wouldn't have to really worry about changing it down here, because here now this thing means the length of the array. But I have to remember that num days is the length of the array. This literally says the length of the array, the length of the array called temps. So this is a better way to write it. So this is our typical traversal of an array. Start at the beginning of the array, go up to, but not including the last entry. We'll go up to the last entry of the array, which is one number less than the length of the array. Remember, the last entry of the array would be one number less than the length of the array, and go up by ones. So look at every entry in the array. That's an array traversal. Okay. Now, here's another example of a program that demonstrates a little bit of array traversals. Okay. What I'm going to do is create, in this case, a pretty big array, but not super big, just kind of big, 500 elements. And I call it random ints, because what I'm going to do is I'm going to fill the array with random numbers. Okay, so I'm going to go through, I'm going to create the array full of zeros. Then I create something called a random number generator. Think of it as like it's like a dice built into the programming language. This thing is an object. It's an object that knows how to generate random numbers for us. And then here's how I ask it for a random number. This is a random number between 1 and 100. Between 1 and 100. What it really gives me, see this thing? That gives me a random number between 0 and 99. You know, I'm not sure why they did it that way. Maybe because arrays start counting at 0. The way this thing works is when you say random int, like if I said if I did that, well, suppose I did this. That gives me a random number between 0 and 54. Okay? But then if I add 1 to it, I get a random number between 1 and 55. That gives me a random number between 0 and 9, including 9. Go from 0 to 9. By adding 1 to it, I get a random number between 1 and 10. Okay? So the next int function on random gives me a random number between 0 and 1 less than this number. Kind of like arrays. We start counting at 0. So this is this is how many random numbers I want. I want 10, I want the range of random numbers be 10 numbers, but they're 0 through 9. And 0 through 9 is 10 distinct numbers. So I'm getting 10 possible, it's a 10-sided, another way to put it is, that's a 10-sided dice where the die faces are numbered 0 through 9. What would be a regular die?
1 to 6.
Yeah, but so that would be what? I would need 6 here, but that would give me what?
0 to 5.
0 to 5. So to get a real die, see, that's where I have to add the 1. See, a real die, we number the sides 1 through 6. The way Java does it, this is a 6-sided die where the faces are numbered 0 through 5. So if I want to model a real die, I add 1 to that answer. And you just have to get used to the fact that programming languages have chosen these quirky little ways of doing things. It might have seemed more sensible to make this a random number between 1 and 6, but that's not how they did it. Okay, what does that give me?
1 to 2.
So, well, no. What does it give me?
Oh, 0 to 1.
Yeah, it gives me either 0 or 1. It's what? It's not throwing a die, it's what?
Flipping a coin.
It's flipping a coin. Okay. Now, if you add 1 to it, then you're getting 1 and 2. If you don't add 1 to it, you're getting 0 or 1. Okay, but this is flipping a coin. I want 2 random its. There's 2 values. There's 0 and 1, and so it's like a coin with 0 written on one side and 1 written on the other side. If I want the coin having 1 written on one side and 2 written on the other side, heads and tails, then I add 1 to it. Okay. Okay. Now I had originally here 100. So that is a 100-sided die with the faces numbered 0 through 99, but I'm adding 1 to it, so I get numbers between 1 and 100. See, I get numbers between 1 and 100. Then I put them in the array. So I'm filling my array with I'm throwing a die 500 times. I'm throwing a 100-sided die 500 times. Okay, so the die has 100 sides, but I'm throwing it 500 times. Okay, if you think about it, that means that every side of the die will probably come up 5 times. Okay, if you actually had a 100-sided die and you rolled it 500 times, you'd kind of expect, since every side is equal probability, and you do this 500 times, you'd figure side 27 comes up about 5 times. Side 28 comes up about 5 times. And if I rolled it 600 times, then I expect each side to come up about 6 times. Okay. Now here I pick one of the sides, and then I'm going to count how many times it came up. So this is a little bit like when we were counting how many days were above average. Here I'm going to say, how many times, I'm going to look through this array and ask how many numbers in the array are that number there. And I picked the last side of the die. I picked side 100. And I want to say, now I should get it about, in this case, it should be about 6 times. Okay. Now what I do is I go through the whole array. See, there's the traversal of the array. If the ith number in the array is the one I'm looking for, I count it. And then I print out how many ones I found. Okay. Now, if I compile this and run it, oh, look, I found 107 times. Is that okay?
Yeah.
What was it? That just means I got a little bit lucky. I rolled the dice 600 times, and my number came up a little bit more than I expected it to. Run it again. Okay, 8 times. I got a little bit luckier that time. My number came up a little bit more than I expected it to. Oh, here I was unlucky. Oh no, here I was exactly what I should get. I expect my number to show up 6 times. That would be the even bet. that would be the fifth, that would be the even bet. That'd be the most likely bet. Sometimes you get all kinds of like, oh yeah, here I was unlucky. My number didn't come up as much as I thought it would. Again, the same. Want to run it every once in a while, you'll get some surprising numbers here. Notice it's staying real close to what it should. Yeah, there's a little bit. We notice how it's staying. This is called the law of large numbers. It's staying pretty close to what it should. Okay. But if I run it enough time, every once in a while, I'll get like there, pretty unlucky. I only got 3 100s. Yeah, so that was kind of unlucky. I should have gotten about 6, and I only got half as many. So that's a little bit of an unlucky run. See, that is, I'd have to do this a lot of, oh, see, there's a good example. I got 11 hits. I should have only got 6, but I got 11. Yeah, I have to do this over and over again and get another one like that. Or, I have to, see, notice if I keep, this is what we call the law of large numbers. See, I'm going to be around 5 almost all the time. But, well, there's another 11. I don't know if I'll see a number bigger than 11. Now, this is what this is where gamblers get addicted to, playing games with this kind of numbers. See, this is literally just, it's just rolling die, and you can place bets on what you think is going to happen. So most of the time, I'll stay close to 6. Now, here's something interesting. What about 6,000 times? Now I'm going to fill my array with 6,000. I'm going to have an array of 6,000 numbers, and I'm going to look for and I'm going to fill it with I'm going to take a 100-sided die and flip it 6,000 times. And see how many times the number 100 shows up. Okay. I should have gotten 60. That would be the expected number. I got 58. 54, pretty close to 60. 65, a little bit more. Okay. Now I'm rolling it. Notice I'm doing it. See, that's 6,000 times. How about 60,000 times? Oh, no, I have to compile it again. See, 574. Notice I'm all the way up to, oh, here's a little trick. See that number is 60,000, but it's kind of hard to read it. Normally we put a comma like that. You're not allowed to put a comma in a number to make it readable. But a couple of years ago, the Java people got sick of trying to read numbers like this. And somebody had the clever idea. The reason you can't put commas is because the comma has too many meanings in the Java language. And putting a comma in a number really means that's 2 numbers in a row, 60 and 0. So they couldn't let you put a comma in a number. Somebody, and this is only a couple of years ago, after Java had been around for 20 years, somebody had the brilliant idea of doing that. You'd think they would have thought of that a long time ago. But so now if you want 60,000, you could put an underscore where we would normally put a comma. Okay, so now I've got 60,000. I'm going to take my 100-sided die and roll it 60,000 times. And Java has no problem with that. Okay. What about 600,000 times? Notice it, my number came up 6,000 times. Okay, I can run it all I want. I'm flipping 60,000 times. Now, what would be the next step up? 6 million times. Okay, so I'm gonna flip my die 6 million times. Notice the program ran. Notice that the program ran just as fast almost as if it was doing it 6 times. I did 6 million times. Okay, what about 60 million? It took a little longer that time, but it still worked. 60 million. Let me show you something this is kind of interesting to watch my program run. Here's a Windows program called Task Manager that lets you watch your computer behave, okay? Here's my use of memory. When I run my program, I want to see if it's actually, I want to watch my memory and see if it uses more memory. Because what I'm asking my program to do is store 60 million numbers. And it didn't even blip over here. So let me go up, let's do 600 million numbers. See, now it's taking a little while to run. And look what happened over here. See that ramp up? That was my program needing a lot more memory to store 600 million numbers. But it's still, remember, see, my computer has 32 gigabytes of memory, 32 billion memory locations. My computer has 32 billion, well, here, actually, I'm saying 16. I have 16 billion memory locations, so I was only using a small fraction of it to store 600 million. And you could see that little ramp up. That was when my program needed that extra memory, okay? And notice I didn't give it up. See, my program took that memory and it's not giving it up. That's kind of a quirk of Dr. Java asked for that memory to run my program, and Dr. Java kept it, okay? Now, if I run this program again, it won't need to ask for all that memory again because it's already asked for enough. No, but then it finally released it, and then it asked for it again. So Dr. Java did a quirky thing. It released the memory it had asked for, then it asked for it back again, okay? And then it hasn't released it yet. Let's do one more. After, now this is 600 million. Let's go up to 1 billion. There's a billion numbers. I don't know if this is going to work. Dr. Java, I mean, it will work, but Dr. Java may not be able to do it. See, my program asked for a lot more memory that time. It's taking a lot longer to run, but it's flipping a die 1 billion times. It's flipping a 100-sided die 1 billion times. And it ran. Oh, it did work. Okay. So see, there was it asking for all the memory it needed to store 1 billion ints. And then when it was done with them, it slowly let go of all that memory. Okay. This eventually, as you learn more about computer science, you'll learn more about this interaction between your programs and the real computer itself. Here we're actually watching my computer. This is called the Task Manager. And at the same time, instead of watching memory, I could have watched the CPU. And you would have seen that let's run it again. And you'll see that the CPU is busy. If I run this again, instead of watching memory, you don't see it so much because there's so much noise going on. Yeah, you don't even see you don't see the CPU working harder. The CPU is flipping a coin 1 billion times, and you actually don't even, it's buried in all this noise of all the other things my computer's doing. It's running Zoom, it's running Dr. Java, it's running the browser. So the flipping of the coin 1 billion times just shows up as noise in here. Okay, so you don't see it doing, but you do see the memory when it asks for all that memory, that storage space. And that's one of the things you'll learn more about as you study more computer science. The interaction, your program is actually running on the computer. So if you use a program like Task Manager, you can watch, if my program used the hard drive, I would see it using the hard drive here. Here I see it using memory, and here I see it using the CPU. And here I would see it using the GPU, if it was using the GPU. And here's where it uses the network. So I would see it using the network. So this program lets you watch your computer work. And if your program uses one of those resources, you'd see it happening. Okay, so this is one of the beauties of arrays. Notice that I can do things in massive amounts. 1 billion coin flips. You know, there was this loop here, since it went from the beginning of the array to the end of the array, it had to traverse all 1 billion items in the array. Okay, so it had to do 1 billion flips of that coin there. Okay, and then I found out how many times, you know, my number showed up, whatever that, you know, about one, or it shows up 1/100th of the time. So this would be 1/100th of a billion, so that'd be what, 10 million, right? Try to do arithmetic in my head. That's, yeah, because we're asking, there's the coin has 100 sides. We're asking how many times one of those sides shows up. So it should show up 1/100th of the time. So it should show up 1/100th of this. Okay, and that would be 10 million. Yeah, that was 10 million. So 1/100th, you take off 2 decimal places and you'd get 10 million. Okay, all right. So notice that we can start playing games. Once we have arrays, we can start playing games with big numbers. You know, before we had arrays, we couldn't do anything in the billions. We could write for loops that would loop that many times, but there wasn't much they could do because we couldn't give the for loop enough data. You know, so we could have written a for loop that looped 1 billion times, but there wouldn't be much we could do because we didn't have that much data to work with. Now the program actually has 1 billion variables to work with. If you try to give this to the Java visualizer, the Java visualizer would complain. The Java visualizer is not going to let you see 1 billion items. Yeah, the Java visualizer would just refuse to run that program because it just works with too big an array. On the other hand, I can run it in the Java visualizer if I use a smaller size. So if you go here and make this smaller, let's make it like, say, 20. Okay, so now we're down to 20. So now we're going to flip a coin 20. We're going to flip a 100-sided die 20 times. And we can actually watch this happen now. Okay, first thing, we get our array of size 20. So there's our array that's going to hold the 20 numbers. Now we create what we call a random number generator. So there's that object that knows how to flip coins for us, how to roll dice for us. Now we enter our for loop. So there's I0. So that's going to be picking a number that goes in that slot. Now start going through. Now we're going to iterate around and around. We pick a random number and it's going to go. So the first random number was 14. Now we increment I to 1. Pick another random number, 92. And I can just go through here. See, there's the random numbers. There's my random numbers. Okay, so now I've got the array fill. Oh, not yet. There. Now the array is filled with random numbers. Okay, so now this loop is about to end. See, the loop ended, and now I'm going to go through. Now I'm going to traverse the array. Well, just one last thing. I'm going to traverse the array again. Now looking to see where the number 100 is in the array, and we can kind of do that ourselves. We can see that. And we didn't get a single 100. See, since we rolled the 100-sided die 20 times, that's not that many times, so we never saw the number 100. So now this loop will have to go through. This loop's going to go through the array one more time, looking for 100s. See, it asks, is entry 0 100? The answer is no, so it's going to skip line 23. And it back up here. Now it goes to the second entry, I equals 1. It's going to ask, is the second entry 100? The answer is no. This is going to be no. So it's going to be back up here. It's going to look at I3, the third entry, which is I2. So it's going to go through the array looking for 100s and not find them. Okay, so that's traversing arrays. Okay, we traverse the array once to fill it. And we've traversed the array once to compare it, pretty much just like our temperature program, where it went through the array once to fill it and a second time to see how many numbers were above average. Okay, all right, so we've gone over, so let's quit there. Next week, we'll still be talking about arrays. We're going to look at lots of examples of doing things with arrays. So we're going to spend a lot of time talking about traversing array for different reasons. If I give you an array, what's the biggest number in the array? If I give you the array, what's the smallest number in the array? If I give you an array, does the number 27, how many times does the number 27 appear in the array? Kind of like what we just did here. So there's going to be lots of what we call searching. They're what we call searching problems. Traversing an array and searching it for some reason for some piece of data that we're interested in. That comes up a lot in computer science. Okay, okay, and so let's go ahead and we'll quit here. Like I said earlier, I'm halfway through grading your exam 2, so I hope it'll be done either tonight or sometime tomorrow. So look for your exam 2, and when you see your exam score, go look for your exam. You know, click on the exam score. Or there's a link next to it, and you should see your exam document with my notations on it, so you can see how I graded your exam, what points you got, what any comments I made. So please look for that. And if you have questions, send me email and send me emails or you know, come to office hours or arrange a meeting. Okay, and Elijah, send me a link right after class. I don't even know how to, I don't know how to talk to you after class in this meeting. I think I just have to halt the meeting. So send me a link right after class, okay?
How do I do that? Just like a Zoom link?
Yeah, send me a Zoom link right after class, okay? Yeah, so send me a Zoom link right after class, because I don't think I can really, I think that'd be the best way to do it. So I'm going to go ahead and stop sharing, and I'm going to end this. Have a nice weekend. We'll meet again on Tuesday. And in the meantime, look for your scores. Okay, bye-bye.